Hello everyone. I wanted to work this problem from the homework set. It was easily the most missed problem. It's a radical equation that involves a lot of computations. So it's very easy to make some arithmetic errors en route. And I think that explains why it was the most missed problem. Before I launch into it though, I want to show you a shortcut that you were supposed to learn earlier in the course. And that was the ability to multiply a squared binomial rapidly without having to go to FOIL. Here, for example, is a binomial and it's being squared. And the technique for that isn't often learned by students. In fact, you can go into calculus courses and see students still using FOIL on this rather than the less risky shortcut method. Less risky because there's less computations, and so once you learn it and learn it well, you actually minimize your chances for errors. Essentially, the way you do this is you take the first term and you square it. In this case, we're going to take a and we're going to square it. And what's going to happen here is we're going to get a trinomial. So we've generated the first term. Now the middle term is the one that's off-putting. That's the one that I think causes everybody to quit the shortcut. Essentially, you have to think of this as being two terms, and the first term is right here, and the second term is the sign and the number that's here. And what you do is you multiply those together. So I multiply a and plus b, and that gives me ab. And then the way you generate that middle term is you then double this. And doubling is the same as multiplying by 2. So that's my middle term here, 2ab. And the third term of the trinomial is as easy as the first term. It's just this term here squared. And b squared is simply b squared. Okay, so we need to work one of these. Let's try this one right here. The quantity 2x minus 1 being squared. Can I do this using the shortcut method? And yes, it's quite easy. The first term squared will give me 4x squared. Now I multiply these two terms together. Basically I'm multiplying 2x by minus 1, which gives me a minus 2x. And then I double that and I get a minus 4x. And then the third term is just this minus 1 squared, which is plus 1. So that's the shortcut method for multiplying a binomial rapidly. I'm going to end up doing that with this binomial right here in the solution. And let's just do that really quickly here. 3x plus 3 quantity squared. Using the shortcut method, you take the first term and you square it, and that gives me 9x squared. Now you multiply these two terms. Plus 3 times 3x is plus 9x. Doubled is plus 18x. Okay, one more term. Plus 3 times plus 3 is plus 9. So that's the shortcut method for multiplying binomials rapidly. And like I said, I'm going to use it twice in this problem. However, the first move is to isolate the radical. Whenever you're solving a radical equation, you must do that. And so I'm going to add this to both sides. And that's what happens here. And I've essentially isolated this radical. And now we take the square of both sides. And that will eliminate this radical from the left-hand side, giving me just 6x plus 7 over there. Now I haven't done this multiplication yet because this is really the shortcut technique. And I'm going to simply drag in the result of this multiplication. And I'll let you on your own see if it follows. You could pause the video and see if I'm following the rule. Here is the result of the right-hand side being squared. Now, once again, essentially, let me create some space here. What we have here is another problem involving a radical. Another equation involving a radical. And so we're rerunning this again. We're going to isolate the radical. And so what I'm going to do is subtract 3x from both sides. And then I'm going to subtract this 3 and this 1 from this side. And of course I'll do it to the other side too. And what I'm doing is isolating this radical right here. And the result of that is this. When you combine like terms and subtract 3x from both sides and 4 from both sides, you end up with this. Now, you might argue you haven't isolated the radical completely because it's being multiplied by 2, and you're right. But it turns out it's better to leave the multiplier of 2 up against this radical. If I was to divide both sides by 2, I'd have a fraction to deal with. So I'm going to leave it like this. And now, once again, we square both sides. And I haven't completed that. I'm just showing it here. And as you can see, here is this binomial being squared that I worked earlier. And the result of this is going to be that 9x squared plus 18x plus 9. And let me drag in that. Now, over here, when I squared this right side, the 2 is being squared, and so that's where this 4 comes from. And then the square undoes the square root, and that's where this 3x plus 3 comes from. And now I do have to do this distribution. And when I do that, I end up with this. 12x plus 12. Let's simplify this a little bit. The right side is now simply 12x plus 12. And hopefully we're in slightly more familiar territory for you now. The radicals are all gone. We had to do 2 isolations and 2 squarings of both sides. But the radicals are gone. And now we are in essentially an earlier section of the book where we use the principle of zero products to solve this. In other words, we make a trinomial equal to 0. And I'm going to do that by subtracting 12x from both sides and subtracting 12 from both sides. And when I do that, I end up with this trinomial equal to 0. And the game is, does this trinomial crack into 2 halves? And it does indeed. It cracks to look like this. And now we're in the situation where we're playing the, we're using the principle of zero products. We have 2 numbers that multiply to 0. So either this is 0 or this is 0. And what we do is we end up setting both of these equal to 0. 9x minus 3 equal to 0 and x plus 1 equal to 0. Of course, you could see that this quantity will take on a value of 0 when x is equal to negative 1. When you solve this little equation here, 9x minus 3 equal to 0, you end up getting 1/3. A value of 1/3 will make this 0. And so those are our 2 answers, ultimately. And this is a very involved problem. You can run the checks on these by inserting 1/3 and negative 1 in the original problem, and you will indeed see that they are legitimate solutions. But lots of computations, lots of talking on my part. YouTube has a limit of 10 minutes per video, so I'm scrambling to condense this problem into sub 10 minutes, and taking some shortcuts and some liberties with you. But I hope I've shown you enough here to get you through this, at least to help you isolate the error you may have made. Okay, I'll be talking to you soon.